High above us, a dramatic battle shapes our winter. The polar vortex versus sudden stratospheric warming, or SSW. These two giants decide if Europe faces mild rain or a deep freeze. The polar vortex locks Arctic chill in place. SSW can shatter the vortex, unleashing Arctic air southward. Their struggle impacts heating bills and road safety. Events like the Beast from the East show how a weakened vortex can transform winter overnight. A strong vortex keeps winters mild and wet. The polar vortex and SSW are key to understanding our planet's winter. Meet the polar vortex, a vast spinning top of frigid air high above the North Pole. In winter, the Arctic chills, forming a powerful cyclone in the stratosphere. The vortex's strong winds lock cold air in the Arctic, keeping Europe milder. This means grey, wet, but relatively warm winters for much of the continent. The vortex strengthens in autumn, peaks in midwinter, and weakens as spring returns. Trouble starts when the vortex weakens or is disrupted. That's when cold air escapes south, bringing severe winter weather. Enter sudden stratospheric warming, the force that can topple the vortex. Sudden stratospheric warming, or SSW, is the polar vortex's greatest enemy. In days, temperatures in the stratosphere over the pole can soar by 50 degrees, a violent shock, not a gentle warming. The cause? Powerful atmospheric waves from below, often triggered by mountains or temperature contrasts, surge upward and break in the stratosphere. This energy weakens the vortex, sometimes splitting it apart. The winds can even reverse direction, and cold air escapes south. While the stratosphere warms, the ground below faces a deep freeze. The effects cascade down over days to weeks, disrupting the jet stream and triggering cold outbreaks. SSW is a dramatic reminder of how events high above can reshape our weather. When SSW strikes, it's a celestial chess match with high stakes. The warming erodes the temperature difference that powers the vortex, causing its winds to falter and the structure to wobble. The refrigerator door swings open and chaos follows. The vortex may split or drift, sending lobes of cold air south. This stratospheric turmoil slowly descends, disrupting the jet stream. The once straight jet stream becomes wavy, with deep dips and bulges. Troughs allow Arctic air to plunge into Europe. Ridges pull warmth north. Often, a blocking high forms over Scandinavia or Greenland, diverting mild Atlantic air and opening the door to Siberian cold. Winds shift, and Europe faces a prolonged, bitter freeze. The path of the displaced vortex determines which regions get hit hardest. This atmospheric battle can reshape winter for millions. The outcome, either a mild season or a historic cold snap. The Vortex-SW clash is the ultimate decider of winter's fate. When the polar vortex stays strong, Europe's winter is mild and wet. The vortex keeps cold air locked in the Arctic, reinforcing a straight, fast jet stream. Mild, moist Atlantic air sweeps across Europe, bringing rain and wind. This is the positive North Atlantic oscillation grey skies, little snow, and above freezing temperatures. Flooding risk rises as rain falls relentlessly, saturating the ground and swelling rivers. The winter of 2013 to 14 in the UK was a classic example. Record rainfall, little snow, and widespread flooding. Meanwhile, southern Europe often enjoys drier, sunnier weather, shielded from Atlantic storms. A strong vortex means less snow and cold, but more rain and storm damage. The same atmospheric feature can create wildly different winters across the continent. The vortex's grip brings its own set of challenges, even without deep freezes. When SSW shatters the vortex, Europe can face the beast from the east. The jet stream weakens and a blocking high forms over Scandinavia, reversing winds to blow from Siberia. Bitterly cold, dry air sweeps west, plunging temperatures far below freezing. As this air crosses the North Sea, it picks up moisture, dumping heavy snow on coastal regions. The result: deep freezes, blizzards, and widespread disruption. The 2018 Beast from the East was triggered by a major SSW. 2 weeks after the event, Europe was gripped by record cold and snow. Roads and railways shut down, and daily life ground to a halt. This was a textbook case of how high-altitude drama can unleash chaos below. The Beast from the East is a stark reminder of the power of a broken vortex. When the vortex loses control, winter can become truly extreme. History is full of winters shaped by the Vortex SSW battle. The Big Freeze of 1962 to 63 began with a major SSW, breaking the vortex and unleashing months of Arctic cold across Europe. Rivers and seas froze, transport stopped, and life became a struggle against the cold. In 2009 to 10, a weak, wobbly vortex, not a single SSW, led to repeated cold spells and heavy snow. The jet stream shifted south, letting Arctic air spill into Europe again and again. In contrast, the winter of 2019 to 20 saw a record-strong vortex. No SSW, no cold snaps, just relentless mild weather. Moscow had its warmest winter ever, and snow was rare across Europe. These cases show the vortex's power, whether shattered or unchallenged. A weak vortex brings cold and snow. A strong one brings rain and warmth. The outcome of this high-altitude duel writes the story of every winter. Each showdown leaves a mark on history and on our lives. Scientists track the polar vortex and SSWs because they're vital for long-range weather forecasts. The stratosphere is more predictable than the chaotic troposphere below. When signs of an SSW appear, scientists know a major weather shift is likely in 2 to 3 weeks. This advance warning helps governments, energy companies, and farmers prepare for cold spells or floods. It's not about predicting a snowstorm on a specific day, but managing the risk of extreme weather. Studying the vortex is also crucial for understanding climate change. Some research suggests that a warming Arctic could make SSWs more frequent, increasing winter volatility. Knowing how these forces interact helps us anticipate the future of our winters. The polar vortex and SSW are keys to resilience in a changing world. The polar vortex and SSW battle far above, but their outcome shapes life on the ground. A strong vortex means mild rain. A broken one brings snow, ice, and disruption. For Europe, the stakes are high. Transport, energy, and health all depend on winter's character. Anticipating these events is essential for modern society. As the climate warms, the rules of winter are changing. Scientists are studying whether Arctic warming is making the vortex less stable, leading to more extreme swings. Understanding this dance is crucial for planning and adaptation. The vortex's silent spin connects us to the planet's climate engine. By watching the skies, we can better prepare for whatever winter brings. Knowledge of this atmospheric duel empowers us all.